Hello and welcome to another exciting episode of the Unthinkable Tech Podcast, the go-to source for the pulse on technology that is shaping our future. I'm your host Anmol Satija, and today's topic is something that you won't want to miss. Joining us today is Amit Singh, who works as a practice head of Java and enterprise architecture at Unthinkable Solutions. He's an expert with 20 plus years of experience in the field of quality assurance, architecture, and system performance. So today's topic is one that tech leaders often struggle to deal with. That is the scalability challenge. How to handle exponential traffic on your digital platform is the question that runs in many minds. So Amit is here to share his valuable insights on understanding system performance, recognizing the right time to scale, and overcoming common challenges companies face during this critical process. So let's jump right into this exciting conversation. Hi Amit, welcome to the show. So good to have you here.
Hi Anmol, thank you for inviting me to the podcast. I'm excited to be here.
Good to know that, Amit. I would like to start from the very basics. So we hear a lot about performance and scalability when talking about software product capabilities, right? So can you break it down for us in simple terms? And why is it important to understand these concepts, like for anyone involved in creating or maintaining digital products?
To understand the performance and scalability of an application, let's first understand the system architecture. So let's say you have to architect a new system from scratch or reviewing the existing legacy system. So primarily there are two aspects of it. The first one, application design or application architecture, that generally cover the functional requirements, use cases, database design, and what code structure and design going to be. And that is good to start, but we have done only the application design work here. Specifically, we have not dealt with any system requirement.
Right.
So the another aspect of application is system design or system architecture, and it's cover the non-functional requirements. So while we are architecting any system or reviewing the existing legacy system, then we not only have to satisfy the functional requirement, but also have to make sure that all the system requirement which are non-functional requirement, they are also met. And that is the primary job of any architect.
Right.
So in non-functional requirement, we focus on the 6 primary factors, and that are performance, scalability, security, reliability, deployment, and technology selection. So our today focus lie on the performance and scalability, and this is part of the system requirement, or we can say the non-functional requirement. So let's first define what is performance. So the performance of any software system is the measure of how fast or responsive the system is under the given workload and given hardware. So here we are keeping these two parameters fixed. First one is the given workload and second one is given hardware. So there are the key pointer of performance are, first one is the speed, so how quickly tasks are completed. Second, responsiveness of the application, so how fast the system react to the user input. And the third one, efficiency, so how well the system utilize its resources, be it the CPU, memory, and the storage. So the next thing is that scalability, which is how to make our system more scalable. So the scalability is about a system ability to grow and manage the increased demand. So let's say if there is a requirement that our system should be able to handle 1 million users, and then how can we achieve it? That if a system suddenly has more user or more data to process, can it handle the load without compromising the performance? So if I talk about the key point of scalability, so that are the vertical scalability, that we achieve adding the more power into the existing machine. And the second one is the horizontal scalability. So adding the more machine to share the load. So our main focus would be in this podcast around the horizontal scalability. One more point I'd like to highlight why it's important. So see, performance and scalability are the fundamental to the success of any software system. So understanding system performance and scalability is a crucial to anyone involved in creating or designing and even maintaining the software solution. So rightly designed system always enhance the user experience, support business growth, and ensure the long-term viability.
Okay. So that makes a lot of sense, Amit. And I think it's clear that system performance and scalability are one of those crucial aspects in keeping applications efficient and reliable, I think. Now, diving in a bit deeper, how can companies identify when it's the right time to start thinking about scaling? What do you think? What are the signs they should be looking out for?
So the first thing to note about the performance problem is that a performance problem is a result of some queue building up somewhere. So any performance problem actually look like or is an actual a queue of requests that is building up somewhere. So it can be network socket queue, IO queue, OS run queue. So we should focus on identifying those areas where this queue buildup can happen, and we should try to avoid that, and that will ensure that we have architected a system that is least likely to face any performance problem. So the next thing would be that there are certain metrics that you should consider when planning to scale the system. So these metrics can help you to determine whether it's a time to improve the capacity of the system or not. So the first aspect would be user growth. So do you expect growth in your user base? If yes, how long it would take? And for that, you can analyze data and trends. Then next thing would be what is expected annual user growth. So understanding the target audience and the potential market size is also a question. Another point we can consider, how long can current setup serve the growing user base without losing the performance. So this includes accessing the resource utilization, database scalability, and third-party services dependencies. Another point we can consider, and that is there are any event or holiday where you observe high demand of your application or heavy usage of the application. So like a seasonal spike, marketing campaign can lead to a sudden increase into the number of users increase. So analyzing these key scalability metrics can provide insight into how well the current setup can handle the growth.
Absolutely, Amit. I think recognizing those early signs is a key to staying ahead of potential issues and at the same time ensuring a smooth user experience. Now, once a company decides to scale, I think the journey has just begun. I assume scaling isn't without its hurdles. So, what are the common challenges companies face when scaling their systems? And as per you, what should they be prepared for?
So see, when scaling a software systems, we always face multiple challenges, and addressing these challenges required careful planning, strategic resource allocation, and deep understanding of existing architecture and system. So the common challenges and what companies should be prepared for, so that is the performance bottleneck. So in performance bottleneck, we generally see and check the latency issue. So as the system scales, the network latency and the data access time can increase. The second, we can see the resource conflict. So increased load can lead to the conflict for the resources like CPU, memory, and I/O. Second, we can address and plan, that is a data consistency and integrity.
Right.
So in this, we can see the distributed data. So ensuring the data consistency across the distributed database and services could be one of our point. Within it, we can also check the transaction management. So handling the transaction across the multiple nodes and the services can lead to the consistency issue. Next one, we can consider the scalability of the architecture. So if we have the monolithic systems, so monolithic architecture can be very difficult to scale horizontally, though we can easily scale it vertically after adding the infrastructure within the same system. But scaling it horizontally is difficult, so we think before planning such kind of system. Next we have that is the service dependency. So scaling the services independently can be challenging when there are the tight independency. Another part I would suggest the load balancing and the traffic management. So effective distribution, so ensuring that load is effectively balanced across the multiple server or instance. Next we can see the spike in traffic. So handling the sudden spikes in the traffic without degrading the performance. So see, these are some common challenges that we should be aware of and prepare for by planning changes to the system.
Got it. I think scaling definitely sounds like a tricky thing to deal with, but knowing what to expect can make a lot of difference, right? Now, once these challenges are identified, the next step would be to actually build these scalable applications. So, how to build a scalable application, or let's say, what are the main components that can help in increasing the scalability of existing applications?
Let's first look at the scalability type and principles. So there are two types of scalability, vertical and horizontal. Vertical is something where in order to scale an application, what we do is we port our application from a smaller hardware to the more powerful hardware. And in horizontal scaling, we just add more hardware. So let's say we have an application that is running on the server and now it's not performing well and throughput is going down while increasing the load. So what we do as a part of horizontal scaling, we bring in more such servers. So here we increase the number of servers to achieve the desired performance. Now let's look at the scaling principle. So there are two principles of scaling. One is decentralization and the one is independent. So these are the two basic principles on which the scaling of application depends. So decentralization means that one component is not responsible for all the different kind of work that is there. If the single component is responsible for different kind of work and all the work that is there, then that is the monolith, and monolith is an anti-pattern for scaling the application. If you have one component and one instance responsible, the entire load that your system is facing, then obviously the system will not be able to scale. The only way you can scale the monolith is you can vertically scale it by getting more powerful hardware. But now we are talking about the horizontal scaling because our goal is to scale our system immensely. So the monolith over here is an anti-pattern. What we want is, if you want to scale our system, we want more number of workers and we also want more specialized worker. So for different kind of work, there should be different kind of workers and there should be more workers. So what we are talking about over here is we are increasing our workforce from 1 to 100 or 1000, whatever number is required to do the entire work. And that is called the decentralization. So a single component is not responsible for everything that has to be done. So there are multiple components of different kind and that will do the same job, and that is called the decentralization. So the next principle of scaling is the independence. So decentralization gave us the lots of worker, but the benefit of lots of worker is there only if these worker can work independently.
Okay.
So let's say we have a lots of worker in our system, but all these workers, they required a coordinator to coordinate some work. Now, coordinator may be required because we may have some shared data that all these workers are modifying. So if we have lots of worker that require the coordination by coordinating the component, then ultimately that coordinator can becomes the bottleneck. So at some point of time, the coordinator will not be able to take up the load. So
Okay.
this system will fail because we are not able to scale up the coordinator. So if somehow we can make our worker work independently, or if we can minimize the requirement of coordinator, then we can increase the amount of independence between our workers. And as we increase the amount of independence between our workers, then we can accomplish more work in the more scalable fashion. So there are these two principles, decentralization and independence, that go hand in hand.
Okay. This was very insightful, Amit. And now maybe we can discuss how to scale the applications.
So to scale the system, we can go with either the vertical or horizontal scaling, as we discussed previously. But here our focus is to scale our system immensely. So we'll go with the horizontal scaling approach because there is no boundary as such in terms of scaling our application. Be it using the infrastructure or increasing the infrastructure, or working on the software system, so increase and scale our application. So there are several strategy and the component involved in horizontal scaling. So let's look at that one by one. So first I'll highlight the replication. So replication involve creating a multiple copy of data or services across the different server or instance to ensure the ability of the fault tolerance. So what we can do, we can go with the database replication. So we can use the master slave concept or master application to distribute the read operation and ensure the data availability. Second, we can choose in the replication is service replication. So we can deploy the multiple instance of a service across the different server.
Okay.
Second, we can choose the services. So what services is? Scaling the services horizontally means deploying the multiple instance of a services to handle the increased load. So to implement it, we can use the microservice to break down the monolith application into the microservice, and that allow each services to scale independently. Second option, we can use the stateless services that design to be stateless so that any instance can handle any request and facilitate easier scaling. Third option, we can choose the caching. It's a very the common word and the famous word in the software industry. So what caching do? Caching involves storing the frequently accessed data in the temporary storage area to reduce the latency and improve the performance. So either you can use the distributed cache and the application level cache. So in distributed cache, you can use the caching system like Redis to store and distribute the cache data across the multiple nodes. On application level cache, we can implement the caching at the application level to reduce the load on a database. So database request can be minimized and that can be solved through the cache. Fourth option, we can choose the partitioning. So what partitioning is? It involves dividing data into the smaller chunk and more manageable piece and distributing them across the multiple server. So we can partition our database. So what database partitioning is? We can split our database into the subset to store the data and to serve the data to the application as a service or direct. Second, we have the consistent hashing that can be used as a hashing to distribute the data every label across the multiple nodes. Another approach we have that is called the load balancing, that can be used after the horizontal scaling to balance the load. So what we can do and what load balancer is? Load balancer is to distribute the incoming network traffic across the multiple servers to ensure no single server become the bottleneck. So to implement the load balancer, we can go with the hardware or software. So there are two approaches. I can use the hardware load balancer or I can use the software load balancer. So generally we prefer to go with the software load balancer, but here I'll discuss both. So in the hardware load balancer, generally we go with the physical devices that distribute the traffic, but hardware load balancer is about a bit costlier, so we generally avoid that. But in software load balancer, we totally depend on the softwares that are easily available in the market, or either the open source. So there are the multiple, the software load balancer, including the Nginx and the cloud-based load balancer like AWS, ELB, Google Cloud, etc. that can be used to distribute the load using the software. So second thing within the load balancing is the service discovery. So service discovery is the process by which the services automatically detect and connect to the other services within the network. So to implement it, either we can follow the static service discovery or dynamic service discovery. So in a static, what we generally do, we can go with the manual configuration of the services to know the address of the other services. But in dynamic service discovery, we can use the tool like the Eureka, Kubernetes to automatically discover and connect with the services. The next options and approach we have that is called the microservice, and it's a highly used, the approach and the architecture that we use for scaling the application. So the microservice architecture involves designing an application as a collection of the loosely coupled, independent, deployable service. So in this, we can call the service boundary and the API gateway. So what service boundary is? To define clear boundary of each services based on the business capability. So here what we do, once we create a services, it means the application, we also split the database as well. So we have the different database for the different services. So load can be easily distributed and it's entirely loosely coupled. Second, we have inside the microservice that is called the API gateway. And we can use API gateway to manage and route the request to the appropriate microservice.
Okay.
Next thing we have that is called the transaction. So handling the transaction in the microservice architecture can be the complex due to the distributed nature of services, but there are the solution of it. So I prefer to go with the Saga pattern, right? So what Saga pattern do? It's a decompose a transaction into the series of the smaller transaction, with each step being handled by different services and provide the compensating action in the case of failure.
Those were some plenty techniques and some great techniques indeed, Amit. And it is clear how these techniques can make a huge difference when managing how a system handles increased demand and delivers a great user experience, right? So now I think let's shift our gears a little, and it is always inspiring to hear real world examples. So it would be great if you can share some success stories where you have helped your clients to overcome the scalability challenge, and how did you do it?
There are many use cases where we have helped our client to scale their system. But to highlight a few, I would like to first mention our latest work. So recently we have done the migration of the application for one of the India leading insurance company, where client was facing considerable operational challenges due to substantial volume of data generated on a daily basis as part of their routine interaction. Thousands of individuals using the client application to submit a crucial insurance policy related document, and this user load and the consistent flow of the document was become the significant hurdle for the system and their internal team.
Okay.
And consistently they were facing the system outage due to such load. So we migrated the application from monolithic to the service-based, and also migrated approx 60 TB data from their on-premise storage to cloud-based storage. Now, we are able to maintain 99.99% system uptime and zero data loss on the time of data migration. They are able to retrieve the data and process the request within the expected time frame now. So another example I would like to highlight that is related to the healthcare industry, for which we have developed the robust emergency response system. The old application struggled to handle increasing the service request. The ambulance booking process was partially manual, causing the inefficient due to outdated third-party solution. These issues made it hard for system to up with the growing need of the healthcare. So to address these challenges, we developed a scalable microservice architecture-based solution. Now the system is able to cater 70,000 plus emergency call on a daily basis, 30,000 plus ambulance are onboarded, and more than 2 million telehealth consultants are using that application on a daily basis.
Those were some great success stories, Amit. Thank you for sharing. And I think these are very inspiring, and it clearly highlights the importance of thoughtful planning and execution when scaling. So, before we wrap up our conversation, are there any final thoughts that you would like to share?
Yeah, see, in the end, I like to say that scalability is the foundation of successful digital products. So scalable applications provide users with the positive user experience, which helps your business to grow. If your application is scalable enough, you can manage user load with the minimum downtime and without affecting the application performance.
Right. Thank you so much, Amit, for sharing your deep insights into the world of system performance and scalability. It's been an enlightening discussion, and I'm sure our listeners have gained a lot of valuable knowledge from it. So as we wrap up this episode of the Unthinkable Tech Podcast, I hope everyone has a better understanding of the challenges and strategies involved in scaling digital platforms effectively. Whether you are just starting your tech journey or you are a seasoned professional, these insights can help you navigate the complex landscape of system performance and scalability. Thank you once again, Amit, for joining us today and sharing your expertise.
Thank you, Anmol. It was a pleasure being here.
And thank you to our listeners for tuning in. If you enjoyed this episode, be sure to subscribe, leave a review, and share it with your network. Stay tuned for more exciting discussions on the Unthinkable Tech Podcast.